Assalamualaikum and a good afternoon to the respected panels, Dr. Nurul Aili and Dr. Siti Hajar. I'm Nisreen binti Mardin from Faculty of Applied Science in Microbiology. Under my supervisor, Dr. Muhammad Nazir Saad, today I will present my proposal entitled High Cell Density Cultivation of Maripane Yeast using Glucose as Low-Cost Feedback, Effect of CI Ratio and Salt Elements. Let me start with something very familiar. Every day, millions of loaves of bread are baked, beverages are brewed, and bioethanol is produced. Behind all of these industries, there is one small but powerful microorganism, which is yeast. Producing yeast at high biomass and low cost is very important, especially for baking industry, brewing and fermentation, biotechnology, and biofuel production. However, industries face a major questions: how can we produce more yeast cells faster and more cheaply without compromising quality? So, this is the central motivation of my project. First, I will explain the background of my study. High cell density cultivation, or HCDC, is important because it helps produce a very high amount of yeast biomass at a lower cost. Maripane yeast, which is Saccharomyces cerevisiae, is widely used in industry because it grows fast and is very robust. Glucose is commonly used as a cheap and efficient carbon source. However, nutrient composition such as carbon to nitrogen ratio and salt elements play a big role in determining yeast growth and performance. In problem statement, even though Maripane yeast is commonly used, there is still limited understanding of how different CN ratios and potassium dihydrogen phosphate, which is KH2PO4 levels, affect high cell density cultivation performance. Most previous studies use fixed nutrient compositions, therefore optimizing is needed to achieve low cost and high biomass cultivation. So, my study focused on two research questions, which is how two different CN ratios and KH2PO4 concentration affect HCDC performance, and how do these parameters influence yeast growth kinetics and glucose utilization. Based on that, my objectives are to determine the effect of CN ratio and KH2PO4 on high cell density yeast cultivation, and to evaluate yeast growth kinetic using batch fermentation. This study is important because it will help increase yeast biomass yield, improve process efficiency, and support low-cost industrial production. This will benefit industries such as baking, brewing, and biofermentation. Next is the literature review. This study focused on four main concepts, which is high cell density cultivation, carbon to nitrogen ratio, glucose-based fermentation, and the role of phosphate in yeast growth. Previous studies show that HCDC increases productivity and biomass concentration, CN ratio controls metabolic efficiency and stress tolerance, and glucose is proven to support reproducible high-density growth, and also phosphate help energy metabolism and stress resistance. However, most studies do not focus specifically on Maripane yeast. There is also a lack of studies investigating CN ratio together with KH2PO4 level at the same time. Therefore, more work is needed to optimize low-cost glucose based on HCDC. Now we move on to the methodology. For stage 1, inoculum preparation. In this stage, Maripane yeast will be prepared at two inoculum levels, which is 5% and 10%, using sterile 0.1 m sodium chloride, and aseptic technique will be maintained. Then stage 2, medium preparation. Medium A will be prepared with glucose as the main carbon source, two CN ratios, which is 20:1 and 60:1, and two KH2PO4 concentrations, which are 0.25 gram per liter and 1 gram per liter. For stage 3, batch fermentation. Fermentation will be carried out in 250 milliliter flask with 100 milliliter working volume, shaken at 180 rpm, room temperature, which is 25 to 27 degrees Celsius, for 48 hours, and samples will be taken at 0, 24, and 48 hours. Stage 4, analytical measurement. Biomass will be measured using OD600 and dry cell width, glucose concentration using DNS method at 575 nm, and protein content using Bradford assay. And lastly, for stage 5, data analysis, the collected data will be statically analyzed to compare treatment effect. For materials, there is a lot of materials that I will be using, but I will highlight the important one, which is I will be using commercial baker's yeast, which is Saccharomyces cerevisiae, glucose as carbon source, and H2PO4 as phosphate source. The main variables include fermentation mode, which is I will be using batch fermentation, CN ratio 20:1 and 60:1, H2PO4 concentration, we're using 0.25 and 1 gram per liter. All experiments will be conducted in triplicates to ensure accuracy and reliability. For expected outcomes from this study, I expect to identify the best CN ratio, determine the suitable H2PO4 concentration, achieve improved yeast biomass using glucose, and develop a more cost-effective cultivation strategy. For limitation and laboratory risks, possible limitations include contamination risk, measurement variation, and glucose inhibition at high concentration. So to overcome these issues, strict aseptic technique will be applied and glucose level will be properly controlled, and also the experiments will be performed in triplicate with proper controls. This Gantt chart shows my project timeline. First, proposal development started in October, including title selection and Chapter 1 writing. Chapter 2 and Chapter 3 were completed between November and December, followed by submission of draft. And lastly, the final proposal submission is planned to submit in January. Here's my reference. All information and data used in this proposal are supported by journal articles and verified scientific sources, which are listed in my reference section. To conclude my presentation, this project aims to optimize high cell density cultivation of myofine yeast using glucose as a low-cost feedback, focusing on the CN ratio and H2PO4 concentration. And I hope this study can contribute to cheaper and more efficient industrial yeast production. That's all from me. Thank you very much for your kind attention.